Today we're doing, again, section 11.1, Intro to Calculus, but this is going to be our second day in the section. So today we're going to discuss approaching limits from one side. So you're going to see different notation. So for example, you will see, assuming a is a number, you'll see a little plus sign, and then you'll see a little minus sign. So this is saying you're approaching a from the right side, and the minus sign means you're approaching it from the left side. And in order for the limit to exist, we kind of talked about this yesterday, that these two things have to be the same thing in order for the overall limit to be approaching a number. So they have to be approaching the same thing on either side. Otherwise, the overall limit does not exist. So we're just going to do a quick review again on graphing piecewise functions. So remember yesterday we talked about making your t-chart. So here is my two t-charts. Let me move that over actually. And so for my first t-chart, it's the top one, and I can only use values that are less than 1. But I'm going to use the value of 1 because I need to know where my open dot needs to go. So I have 1, 0, -1, -2. For the other t-chart, again, I'm going to start with 1 and I need to grow. So for the top one, when I plug in 1 squared is 1 plus 1 is 2. And make a note that that's your open dot. When I plug in 0, I get 1. -1 squared is 1 plus 1 is 2. -2 squared is 4 plus 1 is 5. For my second t-chart, I'm now switching gears to the bottom equation. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7, and so on. So then we're going to plot these 2 points. So for the left t-chart, I have -1, 2. Again, open dot. Then I have 0, 1, and -1, 2, and -2, 5. So notice this piece is part of a parabola. My other piece is going to be completely linear. So I have a 1, 4, and then a 2, 5, and a 3, 6, and so on. So it's growing. Oh, I missed those dots completely. So it's growing in a linear fashion. So this is what our picture is going to look like. I'm going to switch the screen so I have some more room to answer questions about the limit. So I transfer the picture over here. So again, we're going to kind of discuss this idea of the limit. So the first one says, as x approaches 1 from the right-hand side. So my right-hand side is going to be this top piece. So as I get closer and closer, as I get closer and closer to the right, notice the y value that we are approaching is 4. My other side, as I approach 1 from the left, so that means I'm traveling on this piece, I'm traveling this direction. As I approach it from the left, my y value is approaching 2. So overall, the limit does not exist because these two values are not the same. Therefore, the limit does not exist. Again, just to kind of tie in yesterday, if I asked you to find f of 1, the answer would be 4. So let's try another one. Again, I'm just going to give you the picture flat out, right? We're not going to create the picture. We're just going to practice the idea of the limit. So we're going to work on the -2. So as I approach -2 from the right, we're going to be on that blue piece of the function. So as I am traveling to the right, so I go to the right of -2 and I go towards it. And notice I'm approaching a y value of -3. As I approach -2 from the left side, so I'm approaching this x value of -2. As I do that, my y value is getting closer to 0. So again, overall the limit does not exist. And for the bottom one, f of -2 is -1. So notice, I can have all 3 of these different y values that are happening, and a limit can still not exist because they're not approaching the same thing. Just as like a follow-up, I want you to answer in the pop-up block that's about to come, what is the limit as x approaches 0 from the right? And then what is the limit as x approaches 0 from the left? So that's going to be your last question, and after that the video is going to terminate.